Hello everyone and welcome to STEM School. So in today's video, I'll be explaining to you how to do simultaneous equations, and I've got some exam questions to go over, and this will help you have the right mindset when tackling these types of questions in the exam. So before we begin, please do remember to hit the like button and consider subscribing to the channel. I'll greatly appreciate that. Alright, so let's get started. So what are simultaneous equations? Well, they're essentially two equations that each contain two unknown variables, like an x and a y variable, or it could be any letter. It could be an A and a B, okay? It could be any letter. So, for example, the first equation we could be given is something like this: 4x plus 5y is equal to minus 3. And then the second equation will be a similar format. It'll be 6x minus 2y is equal to 5, okay? And what we want to do is solve these equations so that we find the values of the unknown variables. So in this case, we want to solve to find x and y so that it satisfies both of these equations. Okay, so when we actually solve these equations, we can find that x is equal to 0.5 and then y is equal to minus 1. So when you actually substitute x and y back into these equations, you'll find that the left hand side is equal to the right hand side. So that means you've calculated it correctly. You've found the correct values for x and y. So I'll show you exactly how to solve these, and in fact, if you actually do maths or engineering at university, you might have to solve a system of 3 simultaneous equations. So 3 equations and 3 unknown variables. And that's a bit harder to do, but luckily for now at school level it's just 2 equations and 2 unknowns. So what is the procedure to actually solve simultaneous equations? Well, luckily the procedure actually remains the same for any question you get regarding simultaneous equations, which is simple enough, but sometimes it might add a bit of problem solving to see if you know when you can actually solve a particular question using simultaneous equations, okay? So the first step is to rearrange both equations so that you have the number on the right hand side and then the x and the y terms on the left hand side, okay? So just like this format, 3x plus 4y is equal to 22, okay? It'll be a single x and a single y. It won't be an x squared or a y cubed. It'll just be a single x and a single y, okay? And then after you rearranged it, the second step is you multiply through each equation so that one of the variables disappear when you add both equations together. And this will actually become more apparent in examples later on in this video, but essentially if you can imagine the first equation containing a minus 3y and the second equation containing a plus 3y, if you add both equations together, minus 3y plus 3y, well, those will cancel out, so you've gotten rid of the y variable. So that's the whole point of that statement there. So then what you do is you solve to find the first variable, and then you then substitute the variable you just found into any of the equations to find the other variable. And lastly, you can actually perform a check to see if you've indeed found the right values of x and y. So this is a procedure. It remains the same for each type of question regarding simultaneous equations, but you'll see this more clearly in examples next. Alright, so let's just dive into the first exam question then. So this question is telling us to solve algebraically the system of equations 3x plus 2y is equal to 17 and 2x plus 5y is equal to 4. So this is the simplest style of question you could get regarding simultaneous equations. We've been given 2 equations and we have 2 unknown variables. We have an x and a y. We just want to find the x and y that satisfies both of these equations. Okay, so how do we approach this problem? Well, first of all, let's write the equations ourselves. So 3x plus 2y is equal to 17. And what we want to do is number these equations, because this helps you keep track all the different calculations you're doing, and it tells the examiner which equation is which, okay? So we've done that. And like I said, we want to make sure that the equations are rearranged into the form that we want. And luckily the question has given it to us already in the form. We've got the number on the right hand side and then the x and the y terms on the left hand side, okay? So far so good. Now what we want to do is add both of these equations together so that either the x term eliminates or the y term eliminates, right? Now if we are to do that, we have to firstly manipulate them. Okay, so what do I mean by this? So firstly, what you want to do is pick either the x or the y terms, right? So say if I pick the x terms, we have a 3x and a 2x, right? Now what you want to do is multiply both of these equations so that you have the same number in front of the x terms, okay? So we have a 3x and a 2x. We have a 3 and a 2, so that means I can multiply it to get 6x, okay? So let's multiply the first equation by 2, and then the second equation by 3, okay? Because 3x times 2 is 6x, and 2x times 3 is 6x, okay? So far so good. But if we are to add both of these equations to eliminate the x terms, yes, we've gotten the 6x, but we need to make sure one of the 6x is a minus, okay, so that the x terms actually eliminate. So say if I times it by minus 3, okay, so you'll see now in this step what I mean by this. So this multiply the first equation by 2, like we said. So you want to write the operations that we're doing to the side to make it clear to the examiner what we're doing. So 3x times 2, what do we have? We have 6x, then positive 2y times 2 is positive 4y, and then 17 times 2 is 34. Okay, so let's multiply the second equation by minus 3, like we said. So 2x times minus 3, we have minus 6x, and then positive 5y times minus 3 is minus 15y, and then 4 times minus 3 is minus 12. Okay, so hopefully you've seen what we've done here. We've gotten we're now able to eliminate the x terms if we add both of these equations together, because we have a 6x and then we have a minus 6x. They'll eliminate, okay? So I could have easily chosen the y terms instead, because it's just based on preference. So I tend to think of it like just whatever number, whatever pair of numbers is smaller, whichever pair of numbers is easier to multiply to get the same number in front of the variable. So if I chosen the y to eliminate the y variable, we have a 2y and a 5y. I could have multiplied the first equation by, I could have multiplied it to get 10y. So 2y times 5 will give me 10y. 5y times 2 will also give me 10y. And again, you just want to make sure one of the 10y is a minus. So when you add them, both of the equations, the y variables will eliminate. Okay, so hopefully that makes sense. So let's just add both of these equations together. So let's tell the examiner that I'm adding them. So 6x plus minus 6x, well, they will eliminate. Then 4 plus minus 15y, so 4 take away 15y, so that's minus 11y. Then 34 plus minus 12, 34 take away 12, so that will be 22. Now we can actually solve to find one of the variables, in this case is y. Okay, so that was the whole point of this exercise. So we can divide both sides by minus 11, 22 divided by minus 11, and this will give us our first variable of y is equal to minus 2. Okay, perfect, right? So we found one of the variables. Now once you've found the first one of the variables, you can now substitute that variable into one of the equations to find the other variable. Okay, so let's substitute y is equal to minus 2 into equation 1. Okay, just randomly I'm going to pick equation 1. I could have picked equation 2 as well. Okay, just depends, whatever you want. So let's do that. So what is equation 1? It's 3x plus 2y is equal to 17. So let's substitute y is equal to minus 2. So 3x plus 2 times minus 2 is equal to 17. Now let's solve this to find x. Right, so we have 3x, then 2 times minus 2 is minus 4, then we have 17. So you rearrange it, so 3x, so we have 17 plus 4 is 21, then x is equal to 21 divided by 3. So this gives us the other variable of x is equal to 7, okay? So it's just a procedure you need to follow, just a few steps in it, but this procedure remains the exact same with whatever simultaneous equations question you get, okay? So we've now found that both variables, okay? X is equal to 7 and y is equal to minus 2. Now sometimes the exam will ask you to verify your answer. Sometimes that's just an add-on question. So what they want to make sure you're able to do is do this checking step, okay? So what that means is you substitute x is equal to 7 and you substitute y is equal to minus 2. So whatever values you found, you substitute them into one of the equations to make sure that the left hand side is equal to the right hand side. So let's substitute both of these variables into equation 1 just to keep it going. So what is equation 1? It's 3x plus 2y is equal to 17. Okay, so let's substitute these in. 3 times x is equal to 7 and y is equal to minus 2. And that's equal to 17. So 3 times 7 is 21. Then 2 times minus 2, so that'll be minus 4 is equal to 17. So 21 take before is 17 is equal to 17. So the left hand side is equal to the right hand side. So now we can say that our values of x and y are correct because the left hand side is equal to the right hand side. The equation is balanced. That's what you have to say at the end. So like I said, it's just a few steps that you need to remember, but the procedure remains the same for these type of questions. Alright, so now let's have a go at this second question, and this is a different style of question. It's a graph question, and it's telling us essentially, you know, when you solve a system of equations, you find an x and a y at the end. Well, you're essentially finding the intersect point of these two equations. So you have two equations of lines intersecting each other, and the x and y terms that you find is the coordinate of the intersect point, okay? So that's the whole point of this question here. So this question is saying the graph shows two straight lines with the equations 3x minus y is equal to 2 and x plus 3y is equal to 19. The lines intersect at point P over here, and we want to find algebraically the coordinates of P, okay? So if we look at these equations, we have 3x minus y is equal to 2, and then we have x plus 3y is equal to 19. Well, this is just equation of a straight line rearranged. So equation of a line is y is equal to mx plus c, where m is a gradient and then c is a y-intercept, okay? So it's just rearranged to make sure that we have it in the form that we want. So how do we approach this problem? Okay, so first of all, what we want to do is write the equations out ourselves. So we have 3x minus y is equal to 2, and then we have x plus 3y is equal to 19. Okay, and like I said, you want to number each of these equations to tell the examiner which equation is which, and you can keep track of what you're doing. Okay, so we don't need to rearrange it. It's in the form that we want to perform simultaneous equations. We've got the number on the right hand side, and we've got the x and y terms on the left hand side. So like I said, what we want to do is add both of these equations so that we can eliminate either the x term or the y term, okay? So what we want to do is manipulate them somehow, okay? So last question I did the x term, I'm going to choose the y term this time, okay? So we have a minus y and then we have positive 3y. Okay, so we've got a plus and a minus. This is the ideal situation that we want, but now we want to make sure that the number in front of the y is the exact same, because when we add both of these equations together, the y terms will eliminate. Okay, this is quite easy, because if I multiply the first equation by 3, okay, so minus 1 times 3, I'll get minus 3y. And I actually don't need to multiply anything for the second equation, because minus 3y in the first equation plus 3y will eliminate, okay? So this is a simple case, and if you notice, if with the x variables we have a 3x and an x, and that will be similar. You don't have to multiply the one of the equations as well. So let's have a go. So 3x times 3, we have 9x. Minus 1 times 3 is minus 3y, and 2 times 3 is 6, okay? Now the second equation we didn't have to multiply anything, so let's just rewrite that. X plus 3y is equal to 19, okay? Now what we want to do is add them, because we've got a minus 3y and a plus 3y. We can eliminate the y terms, okay? So let's tell the examiner what we're doing. We're going to add both of these together. So 9x plus x, well, that'll be 10x, minus 3y plus 3y, that eliminates. So we have 10x is equal to, so 6 plus 19, well, that'll be 25. Okay, so let's solve this to find x. So we have 25 divided by 10. So this will give us x is equal to 2.5. So we've found one of the variables already. Okay, so like I said, you could have easily chosen the x term to eliminate instead of what I just did in eliminating the y term. Both methods will work the exact same way. Okay, so we found that one of the variables, what we want to do is substitute that variable. So you want to substitute x is equal to 2.5 into one of the equations. Okay, so again, I'm just going to substitute this into equation 1. Okay, what is equation 1? 3x minus y is equal to 2. Let's substitute 2.5, so we have 3 times 2.5 minus y is equal to 2. Okay, so 3 times 2.5. Well, when we work that out, that'll be 7.5 minus y is equal to 2. Okay, so 7.5 minus y is equal to 2. So we have minus y, that's bringing the 7.5 to the right hand side. To take away 7.5, it will be minus 5.5. So this gives us an answer of y is equal to 5.5. You just multiply everything by minus 1. Okay, so we found the second variable. So we have x is equal to 2.5 and y is equal to 5.5. Now, if you scroll to the top here, so the question actually says, find algebraically the coordinates of P. So we want to explicitly say the coordinates of P. You don't want to just say the individual x value and the individual y value. You'll probably lose a mark if you don't write this. So we found x and y, so that means our coordinate for P, the intersect point of the two lines, will be x is equal to 2.5 and y is equal to 5.5. Okay, so this is the final answer. Okay everyone, so that's 2 exam questions on simultaneous equations, and you can see the procedure remains the exact same for each question, alright? And I hope this video has helped you, and if so, please do like the video and consider subscribing to the channel. And I'll see you in my next video where we'll look at inequalities, so I'll see you guys then.